Hello and welcome to this tutorial on the Moore Industries Heart Concentrator System, also known as the HCS. In this tutorial, we're going to be focusing on the Modbus tab of the HCS. So here we are now, we're currently looking at the Heart tab, so let's jump over to the Modbus tab and see what options are allowed there. And you notice in the left-hand column, we have the Modbus communication settings. In these three areas here, and on the right hand column here we have the register formatting for the Modbus. So let's start here on the left. The address, this will be a decimal representation it'd be the address that the HCS is going to use to identify itself on your Modbus network. It's configurable from address number 1 all the way up to 247. The baud rate, it's the speed of the Modbus data transmission. It should be set to match the baud rate of the attached Modbus controller. And click on the down arrow here and you'll see these are the different baud rates that are allowable. So I'll leave it at the default here is 9600. And lastly, we have parity, which by default is set to none. It can be none, odd, or even depending on what your Modbus network requires. And by the way, the data format for Modbus data is 1 start bit, 8 data bits, and 1 stop bit. Okay, so now let's go look at the register formatting here. First section here we have the register grouping. It allows you to select the manner in which to group the Modbus registers. The first one is by variable type, and you notice back here in the Heart tab we have 3 different devices, and each of those devices has like 4 variables, maybe sometimes 3 variables depending on what the instrument is, but it can read up to 4 variables. Oop, I don't want to hit that. I want to stop, go over to Modbus. So in the register grouping, if you have them by variable type, that means it's going to take the primary variable for instrument number address 0, primary variable for instrument number 1, primary variable for instrument number 2, and so on. So all the primary variables will be listed first, and then the second variable, third variable, and so forth. If you choose by Heart device, that means the first Heart device will give all 1, 2, 3, 4 of its variables, and then the next Heart device will give 1, 2, 3, 4 of its variables, and so on. So it's important to know how you are grouping them so that you can use the correct Modbus register address when you're trying to read them. Okay, the floating point word order is next, and by default the Heart concentrator will use the standard LSW. That's the least significant word. This stores the most significant bits in the second register and the least significant bits in the first register. You can also use the swapped MSW, which means most significant word, and that's reverse order of the standard LSW. Okay, so get with your Modbus programmer and he or she will be able to tell you which is correct for your application. The failed Heart devices register value. If one of your Heart slaves on your Heart loop were to fail, this will tell you or tell on the Modbus side what to do. If you hold last value, so if when your instrument failed, if it was reading, by example, 120 degrees, it'll stay at 120 degrees. Preset to, so you can give it a value to go to if there's a failure, or set the output to not a number, so it'll put just a representation up of hex digits that just do not equal a number, and that'll flag, of course, your Modbus controller that something is wrong. And lastly, the integer number of decimal places. Okay, this was a little confusing to a lot of people. It's covered very well in the manual if you have a copy of the manual. But basically what you're doing is defining how many decimal places for the floating point number. And the floating point range, and I'm going to type it down the bottom here, with no decimal places, you can see it here, minus 32767 to a plus 32768. Okay, now if you were to change the number of decimal places, that will give you a better resolution, but also a narrower range. So I'll show you here, if I put 3 decimal places, then your actual range is now minus 32.767 to plus 32.768. You see the range is narrow, but the resolution is much greater. And these are not real numbers, these are floating point numbers that you're reading here. Again, go to the manual, it explains it very well in there, and usually you might want to change it at behest of your Modbus programmer. So there you have it. That's the Modbus tab. And remember, anytime you make a change, make sure you stop monitoring and do a download to your instrument, and that will take all the changes from your screen and download them to your HCS. Okay? Thank you for listening. And at the end of this short video, you see some numbers where you can contact More Industries customer service, and we'll be always glad to help you. Thank you for listening.